Good morning, or indeed good afternoon, depending on where you are in the world, and welcome to DCD Keeping IT Cool, the global broadcast series on data center cooling technology. Over the next 2 days, we'll be providing a deep dive into the future of thermodynamics for information technology, examining the latest data center cooling technologies and innovations, and hosting a much-needed debate on the future of managing higher density deployments. This broadcast is part of DCD's always-on content program for the data center cloud and edge infrastructure industry. We've pulled together a very powerful lineup of industry experts to share their insight on this topic, and I'd like to thank them all for their wonderful contribution. Now, here's a glimpse of our upcoming broadcast schedule, where we'll be looking in depth at critical power, as well as regional data center markets, including North America, Asia, Africa, and Europe. Full details of our 2021 calendar are available at datacenterdynamics.com, where you can register to stream any of the broadcasts for free now. And don't forget that entries for the DCD Global Awards are now open. We have a number of new and updated categories this year, and many of our winners over the years have been involved in innovative cooling approaches and solutions. So do take a look at the categories in the awards website link in the resource box on your screen and start planning your entry today. Now, best of all, everything is recorded, so you don't have to miss a thing. You can watch all of our broadcasts whenever and wherever you like. Just look for the On Demand tab on our website's top navigation bar. And just before I introduce the next episode of the broadcast, let me tell you about some of the functionality that we have built into our broadcast experience. We have a very handy Q&A widget on the screen in front of you that you can use live. Now, us moderators will try to include your questions in the speaker Q&A section, but if we don't have time to cover your question, don't fear, it will be forwarded to the speaker. In the resources widget, you'll find useful downloads and links that are relevant to the session. You'll also find the full live stream schedule here too. On the screen, you'll find a link through to the DCD Connect platform, where you can network with speakers, delegates, and our sponsors. And you'll also find a link to our DCD Pulse survey on the console. Your input will help to inform the industry about cooling and heat removal trends. It takes literally 2 minutes to fill in, and you can win up to $250 worth of Amazon vouchers as a thank you. Many of our sessions have roundtables that follow on from the discussion. These are a great chance to talk with the speakers and your fellow attendees in a much more relaxed environment and share your own views. Now, without further ado, let's get on with the next episode of the broadcast and welcome our next presenter to the stage, Mr. Enzo Greco. Enzo is the Chief Strategy Officer for Nlight Software, where he has a responsibility for setting Nlight strategy and direction based on market trends and dynamics, partnerships, and adjacent markets. Today, Enzo will be joining us to introduce the cooling chain mapping and its ability to assess the downstream impact of cooling failure or maintenance events to improve operations and availability. He'll also present strategies for aligning thermal capacity with workload demand. I'd like to hand over to Enzo to talk us through this exciting new approach to data center planning, operations, and optimizations. Over to you, Enzo.
Well, thank you so much for that introduction, and certainly thanks to everyone in the audience for your time and interest in this topic. And it truly is both a fascinating topic as well as a most interesting time in the data center. And in fact, I'm just going to start. I assume that we are progressing through the slides. And I would just like to start here. So, as I said, it is the most interesting time in the data center. And in fact, to introduce just what we're going to talk about and why I think this is such an interesting time and a particularly pertinent topic, these are the highlights that we are going to discuss in this session. And I'm certainly not going to go through this in more detail. This is really more for your reference, especially when you get the material afterwards. But what we're going to focus on is in the data center itself, aligning workloads with the critical infrastructure, with the equipment and with the building itself, and why that's so important and why that's particularly important now. So if we go directly into the material, this is truly an interesting time for data centers. Even before the pandemic and exemplified and amplified within the pandemic that, in fact, many of us are still managing, data centers have never been more critical. They've never been more strategic. However, I think we'll all agree, they've never faced greater scrutiny. They've never faced greater scrutiny for availability, for efficiency, for flexibility. And what's interesting is there's never been more optionality in the data center market. So to use an economic term, data centers have never had more optionality. If you have an enterprise data center, you have some fairly immediate options. You can use software as a service, you can use cloud, you can use co-location, you can aggregate your different data centers, you can use edge. There are certainly many options. And what is happening is the traditional data center needs to compete with these alternatives. It needs to compete with these options, hence optionality. So the best way of achieving those requirements of efficiency, of availability, of flexibility is to integrate all of those different layers within the data center, rather than having building and critical infrastructure be fiercely independent from IT and workloads. Let's remember that the reason that data centers exist in the first place is exactly to run workloads. It is not for the sake of the building. It is not for the sake of the critical infrastructure, as much as we all love those power and thermal systems. But ultimately, every data center exists to run workloads. So if we are really looking at making these data centers as efficient, flexible, available as possible, we must integrate the workloads with the underlying critical infrastructure that enables those workloads to run. And this concept, this whole segment of the market, is what we focused on as integrated data center management. And it really is the next level of, it's a progression, it's an evolution, it is the next level of integration and management within the overall computing infrastructure that we have, and particularly within data centers. So this, I'm just going to rearrange my screen. So the integrated data center management is essential functionality for managing these data centers, for providing the functionality that we need. And within, we are speaking about integrating workloads with the critical infrastructure. And of course, within the data center, thermal management is every bit, if not even more important than power management. And as we have ever increasing rack density, as we have ever more complex IT infrastructure, in the role of thermal management is becoming even more important. And we'll look at this in more detail in the upcoming slides. So IDCM as an offering, as a market segment, comprehensively unifies all of these different workloads with my IT systems, with my cooling infrastructure, with my overall building infrastructure, to manage everything much more cohesively, much more efficiently. So on the next slide, so what we've done is, this is a very good example. And I just want to highlight one thing. So you may see the Nlight logo there. I just want to take 10 seconds and explain Nlight. So as you heard in the introduction, I'm the Chief Strategy Officer for Nlight. And Nlight is the top provider of software for managing and optimizing data centers. And data centers are complex. They're hostile environments. And we provide the software to manage that complexity to manage that optimization. So that's the one short commercial in this presentation. So what we have in the data center is what you're looking at here is by using this concept of a cooling chain, where now I have my workloads, my IT systems mapped onto my critical infrastructure, mapped onto the building itself. Now what I'm able to do is, for a given cooling unit, what are the downstream effects? So what are the affected IT workloads? And why is this important? Why would we want to know what those downstream IT effects are? Well, thermal systems are mechanical, and as mechanical systems, they tend to have more failure events and certainly more maintenance events than, for example, a power system. So if we have a particular air handler that needs to go under maintenance, what are the downstream assets that are affected? And assets are as rich as they sound. It can be a rack, it can be a server, it can be a workload, or ultimately it can be the users that own those workloads. So it's a very rich approach for integrating the status and perhaps the maintenance and failure events of the cooling system with all of these downstream assets. So now let's look at some of the events in the cooling chain. And I like calling this a practical approach. We've certainly had a lot of experience, and this is a firsthand view of integrating the cooling chain with some real-world events. And also here, I'd like to emphasize why it's so important to include critical infrastructure. So in the data center environment, as we know, our BMS, our EPMS, usually has much lower level granularity in determining issues. Either it is, for example, it's determining power anomalies at a much lower level than you can in software, or it is working within the equipment that we may have. So here, what you're looking at here is our critical infrastructure monitoring. For example, our BMS or EPMS finds a risk to certain workloads. And how do we know that that critical infrastructure will affect those workloads? Because we've defined that mapping within the cooling chain. So now I find my critical infrastructure monitoring system finds this anomaly event. I then want to, again, because everything I'm doing is in support of the workloads, what I now need to do is ultimately move those workloads to a safer place. What is a safer place? And what is that optimal placement for that workload? So now I can include predictive analytics to find that new optimal space for processing these workloads. And how do I actually achieve that? One of the best ways of doing it is through intelligent workflow. And there's several excellent workflow products in the market. But now that I have this underlying signal, I know what the affected assets are. I have a predictive view of where to place and move these workloads. To achieve that, to implement that, I would use a very flexible workload management system. So this is a great example of the cooling chain in action. So then to go a little bit more into detail on that, again, we are looking at aligning workload with cooling. And one of the biggest reasons here is, of course, within the data center, one of the biggest energy users is thermal. And if you look at the data center, a data center is a very interesting type of building in which the building, the envelope itself, is truly affected by what is dynamically running within the data center. If I am running on a Tuesday morning and my systems are running full tilt because of user load, well, my thermal should reflect that. However, on a Saturday morning, I probably have much less IT demand. And therefore, I should be able to optimize and maybe even raise set points within my data center accordingly. In a truly advanced environment, which you may be able to do, what I think a goal should be, is to take your workloads, and again, historically, you know what the important workloads, you can predict their behavior, you can predict when and where you will have peaks. Based on that, again, ideally, if you can aggregate those workloads together into a particular data center, a particular room, a particular hall, whatever is appropriate for your environment, with those applications focused in that area, you can then focus your cooling as well. So aligning this cooling with the workload demand has many benefits from it. It certainly increases the efficiency, and efficiency was one of the things that we started this presentation with. It's one of the expectations of data centers. And later, when we look at sustainability, we'll see why this efficiency is even more important. But what the cooling chain also does is it enhances especially remote management and the autonomous behavior that we need in remote management, because now our critical infrastructure has a much better view of what is actually running, for example, within that edge location. So having this tight integration between the building and the critical infrastructure, and ultimately the workloads themselves, just has many benefits from it. And in a slide, we'll talk about the cooling options that high density may provide to us. So in fact, to look at that aspect of this, so I think we all see, and we probably all experience, and I think many on this call and in this conference have firsthand experience of the growth of high density computing. And it truly is becoming a bigger footprint, a bigger opportunity, a bigger management challenge within the data centers that I believe we all work in. And there are several factors that are driving high density computing. First, we simply have physical space. There are a lot of existing data centers that can be further optimized, that can be further utilized, especially with high density computing. The space is there. Perhaps we have challenges on power and thermal. However, with the concept of the cooling chain, and we're truly able to map cooling with workloads and marry those two, we can have even better utilization of the existing thermal systems. So physical space is at a premium, especially at the edge. I think we all have a sense for that. But then look at what we're running in data centers. There are very intensive workloads that we are now placing in data center, whether it's AI and machine learning, whether it's discovery, whether it's mapping, whether it's, let's call it what it is, whether it's Bitcoin mining or similar types of mining. What is happening is we are rapidly increasing the density within racks and within the data center overall. And look at the kinds of chips, the new graphical processing chips that we are truly jamming and cramming into traditional racks with ever more memory, ever more storage, and they need to be ever more co-located to deal with issues like latency and availability. And then finally, the more we put into a single rack, the easier it is to manage and cool. And certainly we do introduce some additional risk of failure, single points of failure. But I think we all have methods and mechanisms for dealing with that. And again, the cooling chain is a remarkable tool for managing the ever higher density we need to put into racks. So I wanted to marry one of the biggest trends, high density computing, with the reality, with the reality of the cooling chain. So then let's look in a little more detail at the cooling chain itself. Excuse me, at the high density and part of the cooling chain. So some very creative options here. So what some customers have started to do, I think many of you are familiar with this trend, but in lights out data center, I have ever more options and ever more range for what I set my set points and my temperature set points. Without that human elements, I have ever more options available to me. I should take advantage of that. But what is that range? Obviously, we have to be prudent. We have to understand failure. We have to understand what that range is. It may be broader than it used to be, but we still need to manage and be cognizant of the range. So IT and critical infrastructure, they need to be integrated, especially within this, within a high density, especially in a lights out environment. Because again, I have, in many cases, these are remote systems. In many cases, I may want to tailor my cooling based on the IT gear itself. Whether I have the types of servers that I put in different racks have different thermal characteristics. Some vent through the front, some vent through the rear. They have all different kinds of options. And then if I look at what are some of the trends, some of the great trends you've heard within this conference and will continue to hear, I have ever more thermal options. The kinds of cooling that I have, the efficiency and the new approaches, for example, to in-rack cooling, all of those are critical and great options to have. But again, marrying those options with the workloads is the goal that we should be striving for. So then let's look a little bit more at, we mentioned this before, the analytics component. So let's look at this in a little bit more detail. So now that I have a cooling chain, I think we're all familiar with analytics. One of the precepts in analytics is the richer my input streams, the better my ability to find hidden patterns, the better my ability to have predictions within that data. And within the cooling system, certainly within a cooling chain, certainly we have a very, very rich set of input streams, input vectors, because now we have the building, we have the critical infrastructure, we have IT, we have racks, we have environmental, we have user issues, we have workloads. And what we've done in the cooling chain, as you're seeing here, is you can now correlate all those events. So now you see that a particular workload has had an aberration. Perhaps for some reason, it had an unexpected shutdown. Well, what I can now do with it, since I've tightly integrated all my systems, I can now see, was that application aberration, was that application failure correlated with a failure in my critical infrastructure? At the time when that application had a hiccup, was there also a hiccup in my power, in my thermal, perhaps in my environment? Was there a networking issue? So the power of integrating all of these different systems together and tightly forming and bringing those different input streams and doing correlation across those provides ever richer and ever more powerful analytics, both for anomalies as well as for prediction. So what you're looking at here, just as an example, here we are looking at the return humidity on a particular crack unit. And as we know, return humidity is a great leading indicator. In some cases, it's better than monitoring temperature. So here what we're doing is we are looking at return humidity. And based on that, based on the historics, I can then predict out at a point in future, what is that expected return humidity? And remember the example that we had before, several slides ago, where we were saying a best practice for using the cooling chain is to have the critical infrastructure pick up a low-level event and then ultimately perhaps move a workload. You're seeing that in action here. So what's happening here is my building management system, or my EPMS, is getting these low-level signals from the equipment. For example, return humidity. Based on that, we then take that information. We're able to map out into the future with certain confidence in what that range may be. If that future state is within our range, fantastic, great. If it's not, we may want to take an action as we saw on the prior slide. And that action very likely is to manage the workloads accordingly. So a little bit more on analytics. And one thing I want to stress in this slide. So again, we all, just like we've said, analytics are important. We all do analytics of some sort. We always have, whether it's for fault detection, whether it's to predict failures, whether it's to undertake preventive maintenance. Analytics are important. But within the context of the cooling chain, what I find really interesting and really exciting is the opportunity for new metrics. So for example, for a given workload, what is the thermal requirement for that workload? What a fascinating new metric. So when I'm looking at placing workloads, when I'm looking at managing workloads, when I'm looking perhaps at aggregating workloads together so that I can optimize the cooling that I actually use, having that metric, the cooling per workload, is absolutely a very powerful metric to have. And then with that, once I have information on power per workload or cooling per workload, I can then infer what is the cost per workload. Interesting metric. So to run a given workload that I know consumes so much power and has such a thermal footprint, what is the cost for that workload? If I then have a truly flexible environment, as many enterprises do, of where to run workloads, I can now incorporate an arbitrage across different platforms where best to run that workload. And there's also another interesting metric that is often discussed and now being implemented, the concept of risk per workload. So not all environments are similar. I have risk in power, both outside on my utility as well as within the data center. Different equipment has different age. That has another impact on risk. I may have security risks in some areas that I don't have in others. So I also am able to incorporate this concept of risk per workloads. So the ability for these new metrics is yet another new management vector that we have in managing both critical infrastructure as well as the workloads. And we've already spoken a little bit about the end-to-end analytics, but I like putting these bullets in here because they're great reference points for yourselves. So, getting towards the end here, but I don't think we can have a discussion on cooling chains, on thermal, without talking about sustainability. As we said at the beginning, data centers have never been more strategic, they've never been more vital, but they've also never been under greater scrutiny. And one of the areas that I think we'll all agree data centers are truly being singled out is in the area of sustainability. There are often quoted metrics that data centers use between 2 and 3% of the world's electricity. And that's pretty significant. So we have to look at how can we make data centers more sustainable and what's the impact of the cooling chain there. So within the context of the data center, again, sustainability, we are all starting to report out metrics on sustainability, and I think we can all understand that this is likely to accelerate. New metrics are being formed within our organizations and within the industry overall. And we need to both manage as well as report out on these metrics. So we then have, so what could the cooling chain do around sustainability? Again, one of the best is optimizing energy use. And that is really around optimizing the marrying critical infrastructure with workloads. Certainly within sustainability, efficiency is a requirement. And as we've already discussed, sustainability is getting ever more focus, both in the industry as well as within our own companies. But I think we all agree you need new metrics. Many of the existing metrics don't really cover what the goals are in sustainability. So what you're looking at here is some of the metrics that we've been defining, some of the metrics that customers have shared with us on what they need to do in sustainability. So let's start wrapping up. So here is a slide on our just wrapping up many of the points that we've spoken about in this presentation. And certainly, I'm not going to go through these in detail. Hopefully, we've covered these, and these are a good reference point for you when you go back and review the presentation. But it is critical to map, if I were to create the narrative, the elevator pitch of what we've spoken of what we've been speaking about for the last half hour in this session, it's really the importance of marrying the building with critical infrastructure up through IT, servers, and workloads, because that is truly the only way to achieve the ever higher efficiency, the ever higher availability, and the ever higher flexibility that's being required of modern data centers. The cooling chain is a key way of achieving that. And we also need to, with the introduction of high density computing, with the introduction of edge computing, with the introduction of LightSat and autonomous computing, the integrating all of the layers within the data center is becoming ever more important. And that truly is the state of the art. So on the last slide, so we've only scratched the surface here. There is certainly a lot more detail, both at the high level as well as very detailed. But there, I would certainly like to point you to our website, nlight.com. And on there, you will find a great deal of information, again, very technical in architectural approaches for the cooling chain, architectural approaches for IDCM, white papers on how to approach cooling, how to approach capacity management. There's a great resource on integrated data center management for dummies. And I think we've all used these books. They are truly pleasurable reads. I'd like to think that this one in particular is a very powerful asset. And I think it's a very easy read. It's a powerful read that will help you understand IDCM so much better. So again, there are many assets here and some very simple videos that will help you understand IDCM so much better. So with that, I will hand it back. I think that a few questions have come in. I have, so as not to interrupt the flow, I didn't take questions as they came in during the presentation, and I think we have some time at the end here now to address some of those questions.
Absolutely. Thank you ever so much, Enzo. That was a wonderful presentation and introduction to the cooling chain there. I do want to get straight into some of the questions that have come in. So to begin with, you mentioned that the more we put into a single rack, the easier it is to manage ever higher density. Is the cooling chain, is that a tool that's best suited to these higher density environments, would you say?
It is, I don't think it's better suited. I think it is essential it is more essential in a high density computing environment than in a traditional data center. In a traditional data center, certainly the cooling chain is invaluable. I think, especially for the reasons that we spoke about, efficiency, flexibility, and so forth. But as I look at what many customers are doing with high density computing, I think it is really hard to manage those new footprints efficiently without something like without something like the cooling chain. So I think it is almost required wherever high density computing may be.
Gotcha. No, that's helpful to clarify there. You spoke about lights out and edge as well, so I know that it's definitely applicable to those environments as well. Something else you touched on quite a bit was this idea of new metrics and the opportunity which the cooling chain presents for these new metrics. So you mentioned, for instance, cooling per workload and cost per workload, and you touched on sustainability also as examples. Which metric do you think provides us with the most visibility, and which metric would you say that you're personally quite excited about the industry potentially adopting at scale?
I think risk per workload, because it's an interesting question. If you look at all the new metrics that you can introduce, like cost per workload, power per workload, thermal per workload. Those are all very powerful and important metrics. But if you really look at risk per workload, that aggregates many of those others, and it's a fundamentally new approach. So I think that there's a lot to be done around risk per workload.
Gotcha. Okay, thank you. That's helpful. Risk per workload, everyone. In terms of the cooling chain, then, we've had a ton of manufacturers of cooling equipment speak today. Does the cooling chain depend on these manufacturers at all?
It does not, and it should not. So within a typical data center, there is, for many reasons, there are many different types and providers of cooling within the data center. And the cooling chain really needs to incorporate that richness in the underlying critical infrastructure. And the approach that we've taken, again, in defining the cooling chain, is to be agnostic of the cooling equipment. And often one of the best ways of doing that is by integrating with different BMSs. So within most data centers, there is a building management system, a building automation system that interacts and integrates with the different equipment, whether it's power, cooling, sensors, and the building itself. And our approach is to integrate very tightly with those BMSs. And so by taking that approach, there's a very rich set of equipment we can work with. And a long answer to your question, but no, the cooling chain must be able to incorporate all the different manufacturers and the different types of cooling within a data center.
Wonderful. Okay, so it's definitely sort of manufacturer agnostic. Then that's good to know. I have a follow-up question then. So you're speaking about risk per workload as your favorite metric. The follow-up question is there a unit of measure for risk per workload?
So that is the art, because for different customers, risk means something different. For some customers, risk may mean what is the security risk for that given workload. For another customer, the most important risk metric may be what is the availability risk for that workload. So I want to place that workload where it has the optimal uptime chances. So the approach that we take, and I think that the industry is starting to focus on, is risk has a couple of key elements to it that are being solidified. You certainly have security, you have availability, and those are the two prime metrics for risk.
Thank you so much, Enzo. And just going to go back to a question now on equipment. Does the cooling chain control the equipment at any point?
Not unless you allow it to. So we all know that controlling equipment usually is a very rigorous process, as it should be, is a very controlled process, and often it is controlled by the BMS or by a system that is specific to that equipment. So the approach that we've taken with the cooling chain is we will send signals to those underlying building management systems, for example, and then based on user intervention, based on rules, based on automation, based on boundary conditions, whatever the user wants to set, then, if appropriate, that BMS may actually change and control the underlying equipment itself. And I do think that is the right approach.
Thank you very much. Second to last question then. So in regards to the power and cooling chains, is there any best practice in regards to how they interact with each other?
Wow. Interesting question. I would say that the point of intersection should be the cooling unit itself. So in the cooling chain, if I didn't already mention this, I'll emphasize it here. You can define the endpoints. So if you have, for example, if you've defined your data center, if you've defined your cooling chain to be very broad, it may be from the chiller tower all the way down to racks. And that's a very rich cooling chain. So if that chiller fails, I know what all the downstream effects are. But I may also want to make it much more specific. For a given air handler, what are the affected racks? Or I may want to be even more granular, which is if I'm doing in-rack cooling, for that in-rack cooling, what are the servers within that rack? So I have extreme flexibility in how I define the cooling chain. Where does the power chain truly intersect with that? At the cooling unit. I believe the approach I would take and the best practice would be to intersect the power chain and the cooling chain at the cooling unit that you have defined as the endpoint for that cooling chain. Now, certainly you're always going to have cooling chains within the, throughout the data center, within your cooling chain and across cooling chains, but specific to the question of what do I do about power and cooling, have them intersect at the thermal unit.
Thank you ever so much. That's really clear. And then just my last question for you then. So we know that thermal management is one of the most important elements in the data center, and cooling is one of the largest costs across data center operations. Can you explain how the cooling chain might help operators save money on cooling maintenance and optimization? Is that something you could speak to?
Sure. Cooling maintenance and optimization. So two different points. One is if we look at cooling optimization, as we've said, and there should be material in the presentation specifically on this, but one of the biggest benefits of the cooling chain is that you're able to marry your cooling utilization with the actual workload demand. If I have a very quiescent system, my thermal system should reflect that. If I'm under very heavy load, because I'm running batch on Friday evening, my thermal systems need to work extra hard accordingly. So on the optimization, marrying and having insight into the real-time and predictive demand for workloads is how I can optimize my cooling. on the other question that you had around maintenance. So this is a very interesting one. So here, many data centers, of course, are built with redundant cooling, as they should be, N+1, N+2, and even more. And as many of us know, we no longer have that option. So really, we no longer have the option of over-provisioning systems within the data center, which means that when we take the necessary maintenance event within a data center on thermal, which we often do, I now know what are the downstream assets that are affected. Rather than guessing, I know these workloads are affected, therefore I should move those and only those. These are the users that are affected, therefore I should notify those users and only those users. So it gives you much more flexibility, it gives you much more insight into what the effect is of undertaking maintenance, and also when to do maintenance. Because now, if I have a really good view of workload behavior, I know when peak times are, I know when quiescent times are, and based on that, I can very easily and readily determine when is the best time to undertake maintenance. And that is just a fundamentally new type of value that I get from the cooling chain.
Thank you, Enzo. That's very helpful. I appreciate you letting us quiz you for a bit there. There were a fair few questions, so I'm glad we could get to the majority of them. And for those of you whose questions I wasn't able to get to, again, don't fear. I will send those directly to Enzo post this presentation. Now, Enzo, thanks so much again. Very informative, and the fact that there's so many questions means people are super interested. So thanks again for taking the time out to share your insights with us. For those of you viewing, I'm sure you loved that session as much as I did. Please rate the session now on your screen. Obviously, it would be great to get your feedback and be able to pass that over to Enzo. Now, next up at 3 p.m. EDT, we will host our final session of the day, where we'll be joined by experts from Microsoft, Facebook, and Cool IT, an awesome lineup, who will come together to preview the different rack-level approaches to air-assisted liquid cooling, which is an approach that hyperscalers are currently evaluating for their existing data centers. Now, as a bonus, this session meets educational accreditation standards. So if there's any registered DC Pro students who are watching or listening in, you can claim 1 CPD hour by watching this content. So please spread the word. You can join that session in about 12 minutes using the link on your screen, and we hope to see you there shortly. But bye for now.